I will start with the first talk. So it's called Restore and Backup of Elasticsearch Data. So why restore and backup, not backup and restore? So there is this joke about that nobody wants to talk about the backup. Everybody wants to talk about the restore. So that's why I decided to name it like that, and why we are curating the holy art. You will hear it later. There is a tool called Curator, and maybe I try to explain this whole Elasticsearch stuff and restoring and backing up Elasticsearch data or indices like something like walking through a museum. I tried it, so we will see if it works. So so who I am, I'm a senior open source consultant. I'm working for NetWise actually, and I'm a data nerd. Why I'm a data nerd? So I worked many years also at DAS-IT side and bareos side as an open source backup consultant, and today I'm primarily working in the sector of doing Elastic Stack consulting and Graylog consulting. So I cover most of the topics I cover are going about collecting informations, events in the company. So from every node, from everywhere, and to analyze them and to visualize them. So that's actually my main field I'm working in. And if I'm not doing my professional, I'm doing some beekeeping stuff as well. So it's also a bit related to the topic of analyzing or of distributed data. So because in a hive you have a lot of bees and all the informations are going through the hive, crossing the waves, and yeah, it's all a bit connected. So in theory, Elasticsearch. First, I'd like to explain Elasticsearch. So we do a little vernissage of a distributed information storage. So Elasticsearch is an Apache Lucene-based distributed storage engine. So it's a nosql-based storage engine, and it's designed to store informations as I already said, in a distributed way, and it's a part of the Elastic stack. So first it was a single product, so it was the first of Elastic, and then there comes the stack around it. So with tools to catch and to analyze or filter information and then to store them in Elasticsearch. So you can also use Elasticsearch without those tools. You can use Elasticsearch as a storage format for search engines as well. You don't need to use them in this context of the Elastic stack. So that means you can use it also at an indexing engine or something else for applications who need a fast and reliable storage which is fully searchable, like a website search engine, like a web shop search engine, and so on. So how is it working inside? So there's this Elasticsearch index, and he household so-called documents. So an entity is a document. So you have this document, and this document consists of fields. So that's the smallest unit of a document. So these documents are stored in these indices, and indices are divided into shards. And that means you have one indice, but you have several shards where the information is distributed, stored in it. So that brings you in the position that you can spread your data over more than one node. So keep that in mind, more than one node. Yeah. So, and these shards are also divided in so-called segments. So you can have only one segment, you can have more than one segment. So it's all possible. So that means an indice will be created, and it is divided in shards. So I can say how many shards I want. So I want, for example, 3 or 5 primary shards. So that will mean the data is split over 5 shards, for example. So then I also want to say I need more performance. then there came the thing like the ability to balance the shards over nodes if I have more than one. So that means every node receives a shard, and actions like writing and reading, so searches, for example, are spread out over the nodes and the shards. So then we have also the possibility to have replicas of this shard. So that means the data has primary shards and replica shards. So that means you already have your data not once, you have it twice or third times, so 3 times. So you can have many replicas as you want or as your cluster can handle. So that means, of course, they are already maybe safe for using some data, because a primary shard can never be on the same node like his replica. So that means, in other facts, your shards and your informations are everywhere in this cluster if you're running a multi-node cluster. So they are totally distributed. So yeah, then is the question why I should back up then? Because, Tosh, sorry for that, you told me that yesterday, so you had a total loss in your data center. You can prevent a total loss in your data center. So it doesn't matter over how many nodes your data is spread. So if your data center is gone through tsunami, for example, it's lost. Then on the other side, historical archiving or audit or some ISO purposes, each index and shard you are keeping in your cluster is using performance, or he raises up the performance usage. So that means you need resources to hold an index open and readable. So that means every new shard, this performance raises up. And you need more performance. And you also need more storage. So you should back up them also for building up an historical archive, or not only historical archive proposals, so why you like them. So there are also some audits and ISOs which are giving you the advice, or which brings you in the position that you need to keep data more than a year, more than 2 years, or maybe up to 10 years, for example. And then it comes in the hand that you also need to do some housekeeping because of the performance costs, because of the resources maybe you have to handle in an Elasticsearch cluster. So the backup method behind, so explain the art. So what is the art behind? So it works like a snapshot. So it is a snapshot, not like a snapshot. It is really a snapshot. So you have self indices, and you trigger a snapshot of them. So that means during the production time, so you don't have to stop your Elasticsearch cluster. During the production, you can do a snapshot. It will read out the files, and it builds up in the repository a file tree where it orders the different segments and informations and so on. So if you do your next backup, it is not a full backup again or an incremental or something else. It's also a snapshot, and the first and the second snapshot will be merged. So that happens every time if you do a snapshot. It will be merged. The informations will be merged and will be tied up together. So, for example, if you keep an index in your cluster for a month and you do a daily backup base, and after a month you delete the oldest from the first, so you have a 30-day retention, then it will be in your backup 90 days, because the snapshot tool builds up a relation to the first snapshot. So that means after 90 days, your first snapshot will be also deleted in your repository. So in fact, you increase with that technology the amount of retention time besides the production. So that is something also you have to keep in mind. So it compares it with the informations from the indices which are open and alive in the cluster. Then it's also repository based. And it's distributed. We need to tie this information together. Why? We have most Elasticsearch clusters are multi-node setups. And the information is stored, divided into shards on each node. So that means you have a part of your information on each of them. That means all nodes in the cluster have to reach a repository where they can write in or where they can read from. Because all nodes in the cluster during a snapshot time have to do some work. That means, otherwise, one node, a file backup of one node is not enough. So because all the shards together are our picture in the museum. So, what is the conclusion? File backups from a single node are not valid because they are only a part of the data and you can rely on them because they are not constant. All nodes must reach a repository. That means the repository must be online for each Elasticsearch node in your cluster. And you need a storage with a shared read and write access. So that means, for example, a shared file system or an object store. So, the repository, the first thing. There are different repository types, and as I started to take a deeper look into the backup stuff on Elasticsearch Indices, I decided to try all of them. Because all the time I choose the winner, wait for the winner. So there are the possibilities to use ISORT first, S3 object stores. But the conclusion is, yeah, it was possible to use S3 object stores other than AWS, also Amazon Cloud. It was possible until the mid of last year. There was a single line option, and one of the developers decided to remove this option because they never tested it. And since then, you are only in the position to use real AWS S3 object store. So, in other words, burning money. That was the preferred way I wanted to show you, but I decided not to give AWS my credit card information and so on. That's the reason why you will not see it today. Sorry for that. Then there is the other position. You can use HDFS, so the Hadoop file system, which is of course open source, but who has a Hadoop file system? Is there someone in the room? Has someone ever worked with it? So it's not common already, okay. Then you also can use the Azure Object Store. So who has access to an Azure Object Store? Great, you work a lot with that stuff? You work a lot with Azure? Me too. And then there's the last thing, I never saw it in real life, the GCS, the Google Cloud Storage. I never used it. So the winner is the good old file shared system like NFS. Welcome. It's proved, everybody has it. It's cheap. Yeah? It's really cheap. And it comes with no costs. So, or other way, Who has an Amazon account, AWS? Who's working with AWS? Okay, then next year I will show the AWS stuff, so, okay. So I choose because it's, for me, cheaper, faster, and it's easier to show because I don't know how the connection is, to choose NFS. And the important stuff is that this NFS file share needs to be mounted on each node. So each node has this share mounted in his file system. So and it needs to be also configured on each node. That means that each Elasticsearch node needs the exact path to this mount in the file system to use it. So, but that's only the half. So, but you have to configure it in the Elasticsearch service. So building the base, so that means you can configure it already in the Elasticsearch YAML. That means you can start the service already with a configured repo path. And if you configure multiple, then you have also name it in your repository when you announce it to the cluster. If not, and you don't announce it with the full path to the cluster, then Elasticsearch will be used every time the first hit for the path repo configuration of your Elasticsearch YAML. So then the second part is to provide this repository to the cluster. So that means you need to announce it. You can do that with curl. Normally I have some Ansible roles for that, so it's a one-time thing. You know, you have to initialize the repository. So I see the content is cut off, so you will see it in a real-life demo. Otherwise, so it only describes the start of the JSON body. So you need to define the type if you announce it to the cluster. Then you need to do some settings. So you see I put there in the location the exact string. So that's what you have to do if you have no configuration in your Elasticsearch service or you have multiple ones. Then you have to need the exact string of the amount. Then I also activate already the compression for this repository. So so far it's the only good way to influence the usage of a compression in Elasticsearch, at least. So and then you can also use some other settings. So you can throttle the transfer sizes of for reading and writing. So you can. That's, for example, important. So it depends on your purposes and on the size of your Elasticsearch cluster where your data is stored in, and you have a lot of traffic and performance usage during your production hours. So maybe you want not to lose much resources on your backup. So that means you can throttle your backup. You can throttle the in megabytes per second the read and the write usage of the repository, for example, and you can also split the transfer rates into different chunks before you store them. So there are different setup purposes for repositories, because there is also the fact that you can do with snapshotting or backing up Elasticsearch cluster also migration stuff and things, or you can transfer easily data into other clusters. And that means you can use a repository for read and write. So in your production cluster, and for example, you can announce such repository also as a read-only repository in another clusters at the same time or with an URL. So that means you can do, for example, if you switch major releases, you can transfer your data into a new cluster with a newer version. So there are some major release upgrade paths too as well. So you can upgrade a version 2 data into 5 and 5 into 6, for example. And that means you can use one repository with an URL in multiple clusters. So for example, if you have your production cluster and then you have so call it archive cluster, yeah, where you restore, for example, your data if you need if you have to do some researches for data from the last year or some years ago. So that then you can use, for example, a single stack cluster and you can restore it there, and then you can do your search operations and all the stuff in this second cluster, for example. So working with snapshots, so tool tips. You will see first the powerful tool curl. So because Elasticsearch has this rich full HTTP API on port 9200, and you can use it fully with curl. So the whole snapshot API is handling over it, so that means you can do scripting stuff as well. And at least there's also Elasticsearch Python library bind to Snapshot. It's the base of the tool we will talk today about. It's called Curator, and Curator is at least a good choice if you need a fast success in restoring, snapshotting, or housekeeping your Elasticsearch clusters without doing some scripting stuff or doing a deeper dive into the Python libraries or something else, or developing your own Python client. So the curator, he's the one who runs the museum. He's responsible for all the picture collections. So his skills are, he's based on Python. So he also provides a Python API. So there are a lot of Python functions you can use also as singletons. You can use it also as a CLI tool. So maybe it's from interest to make a plugin. Also you can also write your own plugin with that through this API. So it also provides automation with a YAML config, what we will do later. And it can be used for housekeeping stuff like closing or opening and indices and renaming or reindexing indices, besides from doing restores and snapshots. So, consideration for snapshots. If you want to snapshot an index, your data, so it will do a snapshot per default from all your open and active indices in your Elasticsearch cluster. So that means, for example, so I hope it's good in Plex. So you see that? So all these indices, so per default, all these indices you are seeing there, I don't know if it's good in Plex, so no. There is no light version, so it will be hard later on. So maybe we can close the, shall I see? Huh? Or turn off the lights. Can you turn? Thanks. So the default is if I trigger a snapshot, so all my indices which are open, that are actually 4, will be stored in a snapshot. So that means the default is very pragmatic, and it guesses that you want to do a snapshot of all your indices. So it's also important to note that if you triggering a snapshot, the global cluster state will be included. So you can have templates for indices, and you can have cluster settings which are persistent, and they will be also stored with a snapshot, each snapshot. So this is an option which is per default set to true. That means if you do a restore, you are able to also reproduce the cluster, so with the original persistent settings and templates and all the stuff what's behind an index. So The next is if shards are not available from an index, so they are corrupted or they are lost. So the normal behavior of a snapshot is that it fails. So there's a small option which is called partial. That means if you set partial to true, you are able to do a snapshot of a corrupted index with missing shards or broken shards. So through ignoring them, and later if you restore such partial backups, it will recreate the shards which are missing, but they are empty. So that brings you, for example, in the position to restore a corrupted index, for example, or to migrate indexes which are not working as expected. So considerations for restores. So an index can only be restored if it's closed or it exists in the cluster, but it must be in the state closed. If you restore an index, the index will be opened again, exactly like before. And if it not exists, the index will be recreated. So on the other side, restore cluster states can also be activated. Then the default concurrent to snapshotting is during a restore to false. And that means it prevents that you maybe by accident override your templates and your persistent settings in the new cluster. So you have the options what you want to restore. So you can also use the restore functions, for example, to rename or reindex an index, so to alter it. For example, as I explained, you have a document with fields as smallest units, and each of that fields have, for example, a data mapping, a type. So that means you can also alter the definitions of your mapping, so of your entity types. And you can also alter some minimal settings like how many replicas you want. So what's also important during restores, because we will talk about disaster reasons why you want to restore. So a disaster recovery or migration, for example. So that means you have a total loss. So then, for example, I will let all the indices in my snapshot should be recreated, and maybe if I don't remember the cluster settings as well, I want to set the global state to true. And the other thing is, if you restore a snapshot, then the new if you're using and then you should be in the position to use a cluster exactly like the old one. Because, for example, if you have a 2-node cluster and you have 2 shards, or 3 or 5 shards, and you have 2 replicas, and replicas cannot be on the same node like a primary, then you have a yellow state because you getting the fault that the replica shards cannot be assigned to any node. That means if you have 2 shards and you have a replica set of 2, that means you store the data once primary and 2 times as replicas. So one node holds the first primaries, the second the 2 first replicas, and the other 2 replicas cannot be assigned to any host because they cannot be on the same host. For example, that's maybe the reason why you should alter, for example, replica settings during a restore. Maybe because you have not enough nodes. Then for historical search, so you only want to restore a specific index. You set replica shards to 0 because you have a single stack and you need no replication sets because you need no high availability and you need no search performance. And you also do not want to include the cluster state, for example. Because you only want to have the index to search in it, and you don't want to rebuild the cluster. Or for restore for housekeeping, so so that means you maybe, so housekeeping stuff. So you may set the oldest index to one single shard. So that means you create a single shard before you snapshot it. So you compress the data to one shard. Then you can snapshot it, and then you can delete it. And you have a valid backup for restoring. So for example, if you have not enough space in your cluster. So there are many poses, and there are also many pitfalls. So that's why we will take a look in the praxis. So we will leave the theory on that. So I try to share the sessions. So all what we do now, I already checked it into GitHub. So all what we do today is on GitHub with the slides, and you can read it later, and you can maybe use it for some help. So the first thing what we have to do is to create the repository. So we do that as a curl operation. No, not like that. So that means we type it curl like X. So that's input action. And I'm of one of my hosts, so local host 9,000. $9,200. Then I request the snapshot. White background, it's better. Of course I can, so. Ne? Warum macht das nicht? Better? Okay, better. Nice. So we do request you this snapshot API. So now I have to give the repository a name. So that's the part where I name the repository. Repository. I called it NFS repository. So -h, then type content. So that's the thing that we have to type all this. Type application like JSON. So -d type. So and then we type. So I give the type file system. So then, yes, comma. Well, do it in a one-liner type. So, type. Oh. No. Type. FS. Comma. Some settings. Then I put in the location. Elastic data backup. Then I do compress. I hope it will work as a single liner. I never did this before like that. So then we can do it like true. There's no during the settings you need no commas, or? Yeah, no. So acknowledge true. So that means now we have the repository online, and then we can create. So we can verify them. We will see if there's a pretty, so I don't have to pipe it. No, there's no pretty for that option. So I can pipe it in the jQuery stuff, but doesn't matter. So we'll see the repositories will verify as announced to all the nodes. So we have 3 nodes: node 1, node 2, node 3. So, and on the other hand, you can also do this with, for example, a tool like Repo. So you'll see them there, repositories. There should be a new repository, and you can alter also the settings there. You can also delete it. So we will see the 3 nodes. We have verified the that the repository exists, so that means we are finished here. So we created the repository. We have no snapshots actually, so we can do list snapshot, but there's nothing to list actually. So will be empty. Missing exception. There's so there are no snapshots in it. So let's do first snapshot. So doing a snapshot is very simple with curl. So there are several options. Can you see it? Can you see it good, or should I make it bigger or something? Bisschen größer. Okay. So you can trigger it with an with the call repository name snapshot, and this part is the name of the snapshot. So if you write your own scripts and so on, then you have to take care about that you have there an increment or something else. So because you have to hard code in every curl the name of the snapshot you want to trigger. So you have to take care about with a bash variable or something else that it will be changed every time you trigger the snapshot. And the wait for completion true means that it waits until it's finished and you get something like a response. So you can do it like that. So that's a trigger for all indices. Or you can do some advanced stuff. You can only back up single indices with naming them, and you can also say if an index is not available, you can ignore them. You can exclude or include the global state, and you can also do your partial setting here. For example, so ignore unavailable means if one of the indices is, for example, or not valid in the cluster, then it ignores it and it goes over to the next. So if you don't set this option, the whole snapshot will be fail if one index is not online or in a healthy condition to doing a snapshot. So then I already explained the include global state, so to snapshot also persistence settings and templates for your indices, and then the partial setting to ignore corrupted or missing shards, for example. So take a snapshot. So then we automate snapshot name. Okay, so we are close to the end. Automate snapshot name. So there's one thing you can do besides of handle this stuff in your scripts. You can also use when you do it with curl, you can use some built-in variables, but you have to use encoding, of course. And you can use some date math functions as well. So that's one way to doing some automate stuff on a daily backup base, for example. So, and if we pull all that together, we will end into the curator stuff. So backup, YAML. So then we have a curator. And here you can define how your backup should go, and you can have some. You can set some options. You have to name the repository as well. Then you have to give it a name. If you leave it blank, there will be a default. It's listed here, and then you can use all your settings, and you can also do some advanced filtering stuff. So you can tie up multiple filters. What I'm doing here is I'm filtering for pattern and prefix. So yeah, prefix is the beginning of the index name. Yeah, it should be named suffix, but they called it prefix. The filter type on the second hand is age, and the source is creation date, and the direction is older. That means I want to back up all indices that are older than 1 day, and the date for this math should be retrieved through the name of the index. So let's do that. With curator, and then we give it the action YAML. Let's have a look. There's our action YAML. I'm still bareos. So. So you see the configuration of your curator to reach this, and then you see the okay, no, bareos back. So you see the file. So curator. So we will alter the curator -- try run, so we can test it before run backup YAML. So let's do a less, and then we should see. So let's do it like that. So that goes very fast. We'll see if it's there. For example, in the so there's my repository, and there should be no. There is no. Why there is no? So name age. So I'm missing something here. There's the minus missing prefix pattern older than 1 day. There should be 1 at least. No, it's an old one. It's from 6 o'clock. It's UTC, and now it's 8 o'clock UTC. Okay. Okay, then let's try it with bareos. I already prepared it. Beacon, so I already prepared the bareos job. Right, let's see. Bareos, the jobs. So elastic backup, so we'll cut off the try run. So what I used in bareos, for example, I configured an admin job, and I only run the script. Reload, so run job. Elastic backup, yes. So and at least there should be 1. So fail to complete, action snapshot, cannot snapshot, indicate to missing repository. So did not get a repository, why? Is there an error in it? NFS repository of type. Okay, then I will use the old one. So, sorry for that, it worked as I tried it. Yeah. Nope. Huh. Got it. Yeah. So it's good. What happened there? Nothing. Why? So let's see what's going wrong, if the repository is corrupted or not. Select, so snapshot name, backup 1. So we took one by hand, sorry for that. So create, snapshot successfully created. So it did not, backup 1 created. Company database minus, so no, the time string is also in there, so sorry for that, I don't know what's going on there, so no, I will correct that and I will put it in the GitHub repository. So I tried it before with that YAML configuration and it worked, so curious. Anyway, so that's the action for a snapshot at least. So I try to back up all indices which are called company database with a time string which are not only older than, or which are older than 1 day. And on the other hand, there was this restore file for restoring them, where it looks in the repository for the indices called company database, and then it's restoring them without the global cluster state, and it searches for backups with snapshots which are starting with the backup prefix, and then it restored them to the new cluster. So that's what I tried to show, but actually, sorry for that, it went wrong. I will correct that, and you will see it in the GitHub resource. So that's that are some things about backing up Elasticsearch, at least, and how to do that, and some stuff about Curator, which you can use instead of scripting your own. And yeah, thanks.